Okay, in this video, we're going to go over merge sort. On the screen now, we have the sorted pattern of cards. This is what we're going to want the cards to look like after merge sort has been completed and accomplished and the cards are sorted. Merge sort uses a divide and conquer technique. First, it divides the 8 cards into 2 groups of 4. Then it divides that into 4 groups of 2. And finally, it's going to divide all the cards into their own group, so 8 groups of 1. Now merge sort is going to start sorting the cards. So first, it takes the 10 and the 3 and sorts them. Then it puts them into a group of 2. Then it does the 4 and the 6, and because the 4 and the 6 are already in the correct order, it leaves them. The same with the 2 and the 5. And now it switches the 8 and the 7, as they are not in the correct order. And now we again have 4 groups of 2. Next, it's going to turn those 4 groups of 2 into 2 groups of 4. So here we see it sorting the 3, 4, 6, and 10 into a properly organized group. And now it does the same with the 2, 5, 7, and 8. And now finally, it's going to read those 2 groups of 4 and put them into a properly organized group of 8. So first, the order will go 2, 3, 4. Then it takes the 5, 6, 7, 8. And finally, as we get to the end of this, 10. And now we have a successfully organized group, one group of 8, and merge sort has successfully sorted the group. Now, let's talk about the code. Okay, let's go over some of the code of merge sort. Now, there's a lot of code here to go over, so for the sake of time, I'll just go over the main points of it. So the first and most obvious main point is that unlike other sorting methods we've gone through, merge sort actually has 2 functions, merge sort and merge sort helper. Now the merge sort helper is the main function, and essentially once it is sorted, it returns the sorted list. However, you could say the most important function, though is important, but possibly the largest function, is merge sort helper, which indicates whether the list is sorted or not, and it undergoes a separation process. Now, as I said, I'll have to gloss over some details. We have everything commented out, so if you'd like to pause the video, you can look over what each and every line of the code does. But the main parts are that this right here is the separation process, splitting it up and dividing it. This here shows that it's not been sorted. This here checks that it's not been sorted yet and sets it to false, which means it's not sorted yet, so you have to go over the sorting process. And right here we create the 3 main variables that will be used to sort it. Now this here is the sorting process, taking different numbers on the left and right, organizing them into properly sorted lines, and then organizing it back into a larger sorted entity, which then sets it here to be true, and then returns it back up here with merge sort, giving us the list and the time if you want it. The main pro of merge sort is that it's fast. It's almost as fast as quick sort, and it's much, much faster there than random or bubble sorts, especially when you get into the higher numbers. The main con of it is that it's much harder to understand than other sorts. It's also much harder to code, after all it requires 2 functions. This means that especially for a novice coder, or just for someone with less time or less experience, it can be quite difficult to create. However, once it is created, it's very fast. If you want to calculate how long merge sort will take, you use the equation n log n, where n is the number of items that you're sorting. In our case, we used 8 cards, so we use the equation 8 log 8, which equals 7.22, and this number is called the time complexity. Thank you, Mr. Cam, for watching our 3 videos. I hope you enjoyed them.